আসসালামু আলাইকুম প্রিয় দর্শক ও শ্রোতা, বার্তা বাংলাদেশ স্টুডিওতে সবাইকে স্বাগত। দর্শক, আজ আমাদের স্টুডিওতে অতিথি হিসাবে বরাবরের মতো হাজির হয়েছেন আমাদের সেই খুদে পরিচিত মুখ, একান্ত প্রিয়ভাজন, সবাই পরিচিতি অলরেডি সে পেয়েছে ইত্যাদি ইত্যাদি প্রোগ্রামের মাধ্যমে। এছাড়াও তার পার্সোনাল যে চ্যানেল আছে তার মাধ্যমে অন্তত সারা বাংলাদেশের মানুষ, অধিকাংশ মানুষ যারা শিশুদেরকে ভালোবাসে এবং শিশু শিক্ষার জন্য কাজ করে যাচ্ছে, তাদের মাঝে সে অলরেডি নিজের জায়গাটা করে নিয়েছে। তো আমাদের আজকের এই অনুষ্ঠানে, আমাদের এই বার্তা বাংলাদেশ স্টুডিওতে সে আবার হাজির হয়েছে। আমরা তাকে স্বাগত জানাই। সাদ, কেমন আছো তুমি?
I'm fine, thanks. How are you?
আই এম অলসো ফাইন। তো স্যার, তুমি আমাদের এই অনুষ্ঠান প্রতি শুক্রবারে করার কথা ছিল। আমরা বিগত দিনে আমরা এই ধরনের একটা ঘোষণাও দিয়েছিলাম, তাই না, যে প্রতি শুক্রবার আমরা
9 p.m.
9 p.m. আসবো, বাট আজকে কিন্তু সেটা হয়নি। এজন্য
about 10 p.m.
হ্যাঁ, তো আমরা আমরা ক্ষমা চেয়ে নিই দর্শকদের কাছ থেকে, যে দর্শক আমরা সরি বলতেই হবে, তাই না, যেহেতু দর্শকরা ওয়েট করছিল আমাদের এই প্রোগ্রামের জন্য। তো আমরা আজকে তেমন প্রস্তুতি নাই, বিশেষ কারণে এই কারণেই চেয়ে নিচ্ছি যে সেই প্রস্তুতিটা নাই, যে প্রস্তুতিটা নিয়ে আমাদের আসার কথা ছিল ওটা আমাদের নাই। তারপরেও আমরা কিছু কাজ করব, যেমন ও ম্যাথমেটিক্সের উপরে কিছু আলোচনা করবে, সেটাই আমরা যাব। তার আগে আমরা একটা বিষয় নিয়ে মনে হয় আমাদের দর্শকদের সাথে কথা বলতে পারি, সেটি হচ্ছে সেই মহেন্দ্রক্ষণ আজকে রাত পোহালেই, কি জানো সেটা চাঁদ?
The Padma Bridge.
পদ্মা ব্রিজ, ইয়েস। দর্শক, আমরা সর্বপ্রথম মহান সৃষ্টিকর্তার দরবারে শুকরিয়া জ্ঞাপন করছি। মহান সৃষ্টিকর্তার অশেষ অনুগ্রহের কারণেই আজকে আমাদের সেই পদ্মা সেতু নির্মিত হয়েছে, যেটির শুভ উদ্বোধন ঘোষণা করবেন আগামীকাল। আমরা ধন্যবাদ এবং কৃতজ্ঞতা প্রকাশ করছি বাংলাদেশ সরকারের মাননীয় প্রধানমন্ত্রী বঙ্গবন্ধু কন্যা শেখ হাসিনার প্রতি এবং আমার জনসাধারণের প্রতি, যারা অর্থ দিয়ে সহযোগিতা করেছেন, যারা ভালোবাসা দিয়ে, দোয়া দিয়ে সহযোগিতা করেছেন এই পদ্মা ব্রিজ তৈরিতে। আমরা সকলের প্রতি কৃতজ্ঞতা প্রকাশ করছি। আগামীকাল নির্বিঘ্নে সুন্দরভাবে এই পদ্মা সেতুর উদ্বোধনী অনুষ্ঠানটা হয়ে যাওয়ার পরে দক্ষিণ অঞ্চলের বেশ কয়েকটি জেলা যেটার সুফল ভোগ করবে, বিশেষ করে বরিশাল। আর তাদের ইচ্ছা করলেও লঞ্চে তাদের যাওয়া লাগবে না, তারা সেতুতে পাড়ি দিয়েই কিন্তু বরিশালে পৌঁছাতে পারবে। শুধু বরিশাল নয়, আমরা এর আগেই বলেছি আরও বেশ কয়েকটি জেলা এর সুফল ভোগ করবে। তো আমি তো কথা বললামই, আমি ধন্যবাদ জানালাম প্রাইম মিনিস্টারকে, আমরা ধন্যবাদ জানাচ্ছি এই সরকারকে, যারা অনেক পরিশ্রম এবং যে দৃঢ়চেতা না হলে কিন্তু এত বড় একটি প্রজেক্ট বাস্তবায়ন করা কিন্তু সম্ভব না। বিশ্বের কম দেশই আছে নিজস্ব অর্থায়নে এই ধরনের মেগা প্রকল্প বাস্তবায়ন করে, তাই না? তো আমার এই কথাগুলো দর্শকের হয়তো অতটা নাড়া দিবে না, কারণ সবাই সাদের কথা শুনতে চায়, তারা ইংরেজি শুনতে চায়। তো তুমি একটু যদি দর্শকদের উদ্দেশ্যে আগামীকালকের এই মহেন্দ্রক্ষণ নিয়ে কিছু কথা বলো।
So the Padma Bridge is a dream that Bangladesh has been dreaming for years. It is a big bridge and like it helps communicate between people. It helps travel because like which is faster, traveling through a bridge or traveling by a ferry? Traveling through a bridge, right? So it helps us travel and it also helps us communicate because we can go to our loved ones faster and communicate with them. And all this would not have been possible without the help of our Prime Minister Sheikh Hasina. I thank her for getting this project done. It will be done tomorrow. So that's it.
সকল বাংলাদেশের সকল শিশুদের পক্ষ থেকে প্রাইম মিনিস্টারকে একটা ধন্যবাদ আবার জানানো যায়, তাই না?
Yes, we could also congratulate and thank the people who helped in this project.
Good. তো স্যার, আমরা এখন আজকে কি করতে যাচ্ছি? আমাদের দর্শকরা আমাদের কাছ থেকে আজকে কি পেতে যাচ্ছে, আমরা কি করতে যাচ্ছি?
some geography and some math.
ম্যাথ, হ্যাঁ।
Math and geography, I guess.
তো দর্শক, আপনারা সাদের জন্য হয়তো অপেক্ষায় আছেন, আমার জন্য না। তো সাদ যেহেতু তার ম্যাথমেটিক্যাল কিছু টার্ম আপনাদের সামনে উপস্থাপন করবেন, তো আমি সাদকে আমন্ত্রণ জানাচ্ছি। সামনে যে বোর্ড আছে, এই বোর্ডটা তুমি ব্যবহার করে আজকে যে ম্যাথটা তুমি শুরু করতে যাচ্ছ সেটা দর্শকদের উদ্দেশ্যে ডেলিভার দাও, হ্যাঁ। ওকে। তো দর্শক, আমরা আবারও বলে নিই আপনাদের সামনে, বলে যাই, সেটা হচ্ছে যে আমরা প্রত্যেক শুক্রবারে 9টার সময় এই প্রোগ্রামটা করতে চাচ্ছি। আশা করি আপনারা আমাদের সাথেই থাকবেন। তো সাদ, আসো, আমি চলে গেলাম স্টেজের বাইরে।
So, what I'm wanting to talk about is a magic square. A magic square is a square any size. It could be a 3x3, 4x4, or 5x5. It's normally a 3x3 though. It's normally a 3x3. I'm gonna draw a 3x3 square, not a magic square. It's 3x3 square. So it's a square where there are numbers in each of the squares, and all these numbers equal a value in the rows and the columns and the diagonals. They all equal the same number. So, how to actually make okay how to actually make a magic square? Okay, so let's see that. Let's say I want to make a 3x3 magic square. I'll draw it a bit bigger than usual. Draw this. The thing is, we always want to go up. Step 1, we always want to go this direction, like this direction. Like if we are here, we want to go here and then to here. If we are here, we want to go here. And if we are here, we want to go here. So, and one thing, what if we are here? Well, not here, but I meant here. What if we are here? Well, that's where step 2 comes in. This is step 1 and step 2. If you're stuck on a square like this, what you just need to do is just imagine a square is here and then just jump to the other direction. So if we're here, we want to go here. If we're here, we want to go here. So jump to the other direction. So, and if we're here, well, then we want to go here and to jump, and then we jump. So it's kind of like that. And what if we are here? This is where step 3 comes in. In one of the corners, if you're in one of the corners, go down. Go down. That's the only way. Because if you're going to apply the same trick as step 2, there's no box here. Like, there's no box here. So, you need to go down. If you're here, go down. Here, go down. If you're here, then you can go here. You can imagine. Well, actually, you can't. You need to go here, as I told you. As well as like this. No, not like that. Like this. Not like that, not like that. So, these 2 corners don't really count because they have no bottom, and we can just go here and this. But in the upper 2, this 2 counts. This does happen because we can't go here, and we also can't just go. Can't go here and can't just go here. So, now this was really hard to understand. Let's do it with numbers. It'll be a lot easier. It'll be a lot easier. So let's see. One important step though. One important thing that I need to tell everyone who's watching this. And that is, to make a magic square, you need to always Let me draw 3 by 3 again. Need to actually always start here at the top row's middle. This is the top, this is the middle, and this is the bottom. It's the bottom. It's the bottom. So you need to start at the top middle and then go. So I'll just put a 1 here. And also one other thing. If one square is taken and you're like here, if this square is taken and you're here, then you go down and then you continue. So, and then we have 2 over here, jump, we jump again, 3, 4, 5, 6, and now we can't go here, can't jump, so 7, 8, and 9. So our magic square is done. What does this equal to? The top equals 15. Oh, this is also 15. 15. 15 as well. And this is also 15. 15. 15. And 15. Well, I already told those are 15. These are 15 as well. These are 15. I didn't actually need these. I didn't actually need like these. I didn't actually need these. So I'm gonna just roll them off. So our magic square is done. And one thing I noticed is that this is an odd magic square. This is an odd. This is odd, right? Odd. 3 by 3. 3 is odd. 3 is an odd number. So how do we make an even number one? Like 4. 4 by 4. Yes. Let's go one step further. How to make a 4 by 4? Like an even one. Let's see. Let's rub this. Let's rub this. Let's rub this. Let's rub this. Okay, so now let's draw a 4 by 4. Okay? Let's draw a 4 by 4. Like this. 4 by 4. So just gonna draw a big square. A little big one. It seems like it's too big or something. Okay, 4 by 4. Okay, well, wait, let me just rub this off the board. 4 by 4, a bit different. I'm gonna start from over here. And then go here, here, here. So the thing we need to do, first step 1 is forward. You need to go forward. How? We need to go like, you know, like if you're here, we don't go here. We don't go here. We actually go here, not here, not here. What we need to actually think about this is the thing is here. So this we need to go here because, well, forward really means the corners and the center. The corners and the center. So these 4 squares. These 4 squares is the center. Like this is a 4 by 4. And this is a 2 by 2. And this is half. This is half of a 4 by 4. This is half. And this isn't a half. Like not in actual numerical terms, but in geometry terms. We're doing geometry here, right? It's a square, so we're doing geometry. So this is the center, and these are the 4 corners. These are the 4 corners, and this is the center. So we need to go forward along this path, but we need to count these gaps that are left as well. So I'll put a 1 here. I'll put a 1 here, starting with 1. This should be counted though. This is a gap. These 2 are gaps, but these should be counted. So 1, 2, 3, 4, 5 should have been here. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so 16. We've gone to 16, and now step 2. We get to step 2. We need to fill up the other squares. And step 2 is called as backwards. We now need to go backwards. From here to here. So we just got here to here and here to here. We just need to go backwards. We just need to go the opposite of forward. So we need to go backwards. And again, and one thing to remember. This should be not counted as 16. This should be 1. 1 is always the starting point. Because 1 is here. 1 should be also here. We need to actually visualize that as 1. And this as 16. Because we're going backwards. So, and these gaps should be also counted. So 1 should have been here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and now 15. And now 16 should be here, but it's not. It's not here, it's 1. There's 1 there. What if we add up these now? Well, this is a correct magic square. If we add up these, well, the rows, the columns look a little bit suspicious. But that's literally like our trick or something. So 1 plus, let's do the first row and we'll get all the other ones. So 1 plus 15 plus 14 plus 4. So now that is equal to 34. Because, well, 1 plus 15 is 16, 16 plus 14 is 30, and that 4 added is 34. So this is 34, which means this is 34, which means this is 34, which means this is also 34, 34 again, 34, 34 after 34. Every single thing is 34, 34, 34. If you add it up, it's 34. So the thing is, we need to do it like this. And one suspicious thing I noticed. One question I want to ask you. One question. Let me just rub this off the board. Just rub everything. We're still not rubbing the magic square though, because we're actually teaching magic squares. So, in a 3x3 magic square, imagine that the number that we start with, the lowest number in our magic square, is the number n, and the magic sum, which is, the sum of all the columns, rows, and diagonals, is x. I'm just writing this one. I don't want to use up too much ink. So, and if this is true, what is the value of n and what is the value of x? Like, you might think, well, it could be any value. We could choose any value. Like for n, we could choose 1, 2, 3, 4, and that also affects the value of x. But I'm saying, what is the relationship between these two? I'll give you some time. I'll give you 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10. Now here's the thing. We need to actually write all the other values to get x and n. We need to write all the other values, like this much space is left. So after n we have, you guessed it, n plus 1 over here, jump. We get n plus 2 over here, n plus 3, n plus 4, n plus 5, and now n plus 6, n plus 7 over here. You might already find the answer to it because I just draw this. You already see that n plus n plus n plus n plus 5 and n plus n plus 4 plus n plus 8. We'll write this one. So let me write it. n plus 7 plus n plus 5 is equal to x. Wait, let me try it x again. That wasn't good. That wasn't so good writing x. So let's evaluate. So now we have 3x's and so we can put them together because this is addition and it doesn't matter. So we can put them together. Okay, so and now we can n plus n plus n is equal to 3n, right? 3n, we've learned this. 3n. And now we have 7 plus 5 on this side. 7 plus 5 is 12. So our final answer for x, we have our final answer, x is equal to 3n plus 12. This is for x. But you also might notice this. This is also equal to x. This is also equal to x. But, you know, like, these are still n's though. There are still n's here. So we still have 3n here. And 4 plus 8 is still 12. Still 12. So this is the value for x. This is for x. What about for n? Well, we need to compare and evaluate again. So we'll go from here. We'll go opposite. So, well, the order of operations are a set of rules to do things first. So parentheses we need to do first, then exponents, then multiplication and division, then addition and subtraction. But we're trying to undo things here. We're trying to undo things. So that means we just need to use the order of operations in reverse. You need to use that in reverse. Just the order of operations reversed. That's it. So, what do we have then? Well, first, you might think we need to undo this last, because it will be did first. We need to undo this last, and that's correct. If we undo this first, it's not going to be correct. So we need to undo this last. We need to undo this first. So we got, n plus 12 here, 3n plus 12. We need to go and get this out. So we subtract 12 from both sides. Let's subtract 12 from both sides. On this side, these cancel, leaving just 3n. And this side we have x minus 12. Now, we need to do this. We divide by 3. These cancel out. And here we divide by 3. Which means n is equal to x minus 12 over 3. Whoops, sorry. And one thing I really want to point out. You might think, why did I put this O here? Like, I could have put both separate or just one. Just one wouldn't work, obviously, but I could have put both separately. But that's also not correct. Like here's how. X minus 12 over 3 over 3. So what we really need to do is we need to just find an example which doesn't qualify this. Just need to find an example which doesn't qualify this. So let's take 1 for example. What if we take 1? 1 as n. Then x is equal to 15 because we already checked that. We already saw a 3 by 3 magic square starting with 1. X should be 15 then. So what if we do all the calculations? 15 divided by 3 minus 12 divided by 3 is equal to n. So now the thing is subtracting this all is we need to not subtract these. That will result in 0. 3 over 3, which is equal to 1. So it seems like it works. It could work here, because basically just 1. What if we try another one? What if we try another one? What if I try n is equal to 2? Well, n is equal to 1 is just 1. But there are 9 squares in a 3 by 3 magic square. We're increasing the values by 1. So we're increasing it by 9. So it's basically we're increasing it by 9, but in a row or column it's 3. So there are 3 numbers. So we're literally increasing it by 3. We're increasing it by 3. So x should be 18, right? Right? Well, let's check. Let's check for 1 second. Let's draw a tiny magic square over here. Really tiny, small. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10. So now let's just add 1 column and we'll get everything. That's 18, and we are correct. So x is equal to 18 then. What if we do it now? 18 over 3 minus, 12 over 3. If you do this now, 18 minus 12 we get, which is 6. 6 over 3. 6 over 3, and that's 2. So it seems like we are correct. So there are actually two solutions for n. X minus 12 all over 3, and another one, x over 3 minus 12 over 3. But one suspicious thing. These are both numbers, so you can solve this. You can actually solve this. So this is equal to 4. So this is actually 4. 12 divided by 3 is 4. So x divided by 3 minus 4 is also another solution. Well, let's try it if that's really a solution. So what if we take 18 again? 18 divided by 3 minus 4. Well, the thing is, this is not a fraction. So you think that it is impossible to subtract that. But you are wrong if you think that, because it is a fraction. Yes, how? Well, here's how. Everything, like x divided by 1, like let's say we have a variable c divided by 1 is always equal to c, right? This is correct. We've learned this in kindergarten school. Divided by 1. Dividing anything by 1 does not change its value. We don't need this. So, what if we take 18 divided by 3 minus 4 divided by 1? Like this does not change the value. This absolutely does not change the value. Now, to do these kinds of addition and subtraction, we need to first multiply. We need to multiply this. Like, we need to take this, get it here, and get it here. 3 divided by 3. Let me just rub these arrows off the board. Okay. 3 divided by 3 we have on this side. And we also have 1 divided by 1 on this side. So 1 divided by 1. So now this is obviously 18 over 3. This will get us 18 over 3 anyway, because we're literally multiplying by 1. Minus 4 times 3 is 12. 1 times 3 is 3. We literally got the same thing. We literally got back to the same thing. So this this, we literally go back to the same thing. This is basically the same thing. 18 divided by 3 minus 12 divided by 3. We got it from 18 divided by 3 minus 4. So this is basically the same thing. So these are the two solutions. So the answers to those questions are x is equal to 3n plus 12 and n is equal to x minus 12. Wait, let me just write n here over 3. Let me just write a bit bigger. Over 3 or, let me write or here instead of a comma. Or, wait, let me write or in capital and bigger. So or x over 3 minus 4. So those things work. It seems like those things work. Those things absolutely work. So this is the answer to that question, and this is the end of this, mathematics magic square class, I guess. I'm done. So thanks everyone.
Next video next video.
Please watch our next video of this program.
Thanks.
Thanks.